If I throw a pass to Harvey and Navreet intercepts it, what does that mean? She crosses the path and catches the pass, right? Excellent. So an x-intercept is what? Right. It is where a graphed line crosses the x-axis. Yeah, yeah? Yeah, yeah, yeah. And what is the y-intercept? Duh. It's 8 seconds later. What's the answer? Where a graphed line. Keep going, Harv. Look at this guy. He's on fire. Crosses the... Harvey. Marvelous Harv. Harvey. All right. Yes, yes. Take your bows. Everyone, Harvey will be appearing here until the end of July. Tip your waitress. Everybody understands this, yes? So, in this big white space here, let's draw the Cartesian plane, which is what this thing is called. Actually, they call it a coordinate grid because they don't want to give any credit to an old European white guy anymore because other people invented this as well. And let us draw another line that goes like that. Where do I put the red dot for the x-intercept? Is it there, point A, or point B? Point B, excellent. Oops, that's supposed to be red. Dumbass. Where does the green dot go? Duh. At the other one, right there. Everybody cool? All right, now I want you to draw 4 more lines that have an x-intercept and a y. No, we don't need 4. We need 2. Draw 2 more lines. One. I don't want it to be green. I want to use different colors. Purple. Now pink it is. And let's go with orange. Everyone agree? Everyone cool? Okay. The red dot, of course, is there and there. And the green dot is, of course, there and there. Now, you have 3 x-intercepts and 3 y-intercepts right now, correct? Everyone agree? What are the coordinates of this one? What are the coordinates of that red dot? Can you tell me the coordinates of that red dot? Can you? No, you cannot. Can you tell me half of the coordinates of that red dot? What half? The 0. This is some value of x with a y value of 0, yes? What is this red dot? It's some value of x and what? 0. What is this red dot? Some value of x and 0. What is this green dot? Some value of y and... So how do I write it? 0y. What is this one? 0y. What is this one? 0y. So now, what can you tell me about every single x-intercept in our universe? What are its coordinates? X, 0. What is every single y-intercept in our universe? 0, y. Now, if I were to put those into a table of values, what would this be? X, 0. What would this be? 0y. Now, ladies and gentlemen, that is the only concept you have to understand for this entire unit. If you understand x's and y's live on this thing, you all will get 100% on this unit because that's the only concept that you need to be able to understand. Do you all understand that? I hope so. Let us carry on. Good job. Was it you or him? It was you? Nice. Okay. Here we have what kind of notation? What do we call that? Starts with an F, ends with an N, has unction notatio. Function notation, yeah! Now, function notation was a new thing this year. Back in the old days, we called that y equal 2x plus 3. And we put it on a table of values, yes? All right. I want to know the x and y intercepts for that. Well, duh. Every x-intercept is x0. Every y-intercept is 0y. Here is the only concept for the whole unit. Y equals 2x plus 3. What do you see there? X. So what do I write there? Not 0. X is x. So what do I write there? X. What do you see there? 0 is what letter? Y. What do you see there? Y. So what do I write there? 0 equals 2x plus 3. What's your job whenever you have a single variable? Starts with an I. I don't even get to finish the joke. Good job! Everyone's getting better! Yeah! What does x equal? No. Now you got to do some algebra. -3 over 2. That's what x is. Now, what do you see right there? Where the pink circle is? X. What does x equal? So what can I write right there? -3 over 2. Only concept you need all day. What about the other one? Y equals 2x plus 3. What does x equal? 0. So what do I put here instead of x? 2 times 0 plus 3. What is 2 times 0? Plus 3? 3. Y equals 3. What do you see right there? What does y equal? 3. So now I don't have any x's. I don't have any half coordinates. I have full coordinates, don't I? Why is the x-intercept a pain in the butt? Because it's a fraction. I have two options. One, I could go out to 1 1/2, and I could put the dot right there, halfway between 1 and 2. It's really hard to see because I've made it so small. But I could put my dot right there, halfway between 1 and 2, couldn't I? Right? That's one option. A better option, the option that you should take, is this one. Change the scale. Why? Because you're in charge of this graph. If I make this 1, then this is 2, correct? And 1 1/2 is right here in the middle, and it's yucky. But if I do this, if I make this -1 and this -2, where is -3/2? Right there in the middle on one of the points. Does everybody see what I did there? Who's in charge of the graph? You are. How do you show me that you've changed the scale? By showing me that you've changed the scale. Everybody understand? Now what's my y-intercept? 3. So, if I keep the same scale, then this is 1, right? Where's 2? How far up do I go before I get to 2? I got to go 2 squares. Then until I get to 3, 3 squares. And there is my y-intercept. 3, 2, 1. Does everybody understand? This is what all of your future math teachers are going to want you to do if you can. They don't want you, if you can avoid it, putting dots in the middle. Everybody cool? But sometimes you have to. Everybody okay? All right. I'm going to leave it zoomed in this big because we're going to be doing graphing. Real quick reminder of stuff from the last unit because you haven't written your tests on it yet. What's the domain and range? Everything. Of which? Both. Because can I take every single x in the universe, multiply by 2, and add 3? Yep. And if I have every single x in the universe, I must have every single y in the universe, right? So the domain is x is all real numbers, or negative infinity to positive infinity. Y is all real numbers. Everybody cool? All right, let's go on to a slightly more difficult one. What makes this one harder? What makes it harder? Fraction, but is it really harder? No, because it's the same math, isn't it? What is every single x-intercept in the world? Every single x-intercept in the universe. What is it? There's that 8-second attention span. What's every single x-intercept in the universe? Turn back a page. No. Every single x-intercept in the universe is what? X0. What's every single y-intercept in the universe? 0y. Now, all we do is we work with that. The first one in red for the x-intercept, what value is x? X. So I have 1/2 x plus, not plus, you idiot, minus 2. And what does that equal? 0, because y is 0. Then I do math. 2 equals 1/2 x. X equals what? No. What does x equal? How do I get rid of divide by 2? Multiply by 2. So what does x equal? 4. X equals 4. What letter do you see there? So what can I write there? 4. Then the other one, y equals 1/2 times 0 minus 2. Y equals -2. What do you see there? You see a y. What does y equal? -2. Now, can I draw my graph? Yup. Because I put a red dot at 1, 2, 3, 4, 0, and I put my green dot at 0, -2, and I connect the line. Will that line go forever in both directions? Yes, of course it will, because every single number in the universe can be cut in half, and 2 can be divided or taken away from that result. Everybody good? Spectacular. I'm going to stop there for a moment because it is approaching break time. And actually, no, I'm not, because this page fits nicely with what we just did. So I'm going to jump into second block for only about 7 minutes. You people are very intelligent people, and Madeline has already mentioned this. You've all already seen it. But I want to call your attention to a couple of things. The first thing I want to call your attention to is that letter right there. Please notice that letter right there appeared right there, didn't it? A letter after the X. And it appeared right there, didn't it? Now you should notice something. It appeared there, plus 3. It appeared again right there. Y-intercept was plus 3. It appeared right there, negative 2. The y-intercept was negative 2. Something has now happened twice in math, which means what? It will always happen. This number right here is the y-intercept. But there's some rules about that. It's only the y-intercept when y is isolated. Please highlight that. Don't write down what I'm about to write down. Just answer the question. Y equals 3 minus 2x. What is the y-intercept there? 3. Even though I wrote it in a different order, the y-intercept is 3. Everybody cool? Again, don't write down what I'm about to write down. Just tell me the answer. What's the y-intercept there? You cannot tell me yet. Why? Because y isn't isolated. Is everybody good? Okay. What is the y-intercept here? Can you tell me right now without doing any more work? No. Why not? Because y isn't isolated. Is everybody cool? As long as y is by itself, whatever that number is the y-intercept. What about this one? Now what's the y-intercept? 1/4. Does everybody get it? Okay, good. Next thing. That covers the b. We already know what y and x are, don't we? What is this made of? X's and y's. We already know about them. We learned about them in grade 6 or whenever you first learned this stuff, yeah? Actually, you learned about it the first time you played Battleship when you were like 4. Because everybody knows how to play Battleship. A8. Hit! Oh! Unless you cheat, like I used to do to my brother. I would put all my ships on the board and then move them around. And then my brother figured out I was moving them around. So the next time I played, I took all my ships off. Every turn I would take a ship off. And eventually my brother would go ape. He'd be like, you got it! And then he'd grab the board, he'd turn it around, you don't have any ships! And then he'd throw the board because my brother had anger issues. And I was like, because that's what big brothers do. Remember, he ruined my life when I was 21 months old when he came along. Anyway, so we all know what y and x are. What's the only letter here we haven't talked about? M. M is the slope. We have already seen slope. Slope is a rate of change. And we already defined that as change in dV divided by change in IV. That's how we have used it. But in general terms, when we don't have a specific dV and a specific IV, it becomes the change in y divided by the change in x. And that is what we're going to discuss right here before the break. Everybody put Cartesian coordinate grid with this line. Right? Okay. What are the coordinates of that red point right there? Can you tell me? No. So what you have to do is say that is negative x, negative y, correct? Everyone agree? And what is this point up here? positive x, positive y, yes? If I wanted to get from here to here, I would have to go up on the y-axis, wouldn't I? Which is positive. Agreed? Then I would have to turn right on the x-axis, which is positive. Agreed? So my change in y was positive because I went up. My change in x was positive because I went right. If I do positive divided by a positive, I get a positive number, don't I? So this is what we call a positive slope. Now, one of you clowns is going to say, oh, Mr. Myers, I want to go the other way. Okay, kid. To get from the blue y to the red y, I would have to go down, right? Which is negative. Then where would I have to turn? Left, which is negative. So I have negative divided by negative. What is that? That's a positive as well. So you don't get to say, got it? Okay. So what's this one? Obviously. If this one leans this way and it's positive, what's this one? Obviously, even if you hadn't seen it before. It's a negative slope. Because, and I'll use two different colors, if I went from there to there, that's positive, that's negative. If I went from there to there, that's negative, that's positive. So that is what we call a negative slope. Now these two are a pain. How do I get from there to there? It's positive up, isn't it? What is my change in x? Nothing. So it's a positive divided by 0. What is that? Can you even do that? No. This is what we call undefined or an infinite slope. I like to think about it as skiing. If I were skiing right here, could I ski that? No. That's called falling. Right? I die. That is not a slope you could ski. Now, I could do that awesome thing some crazy-ass skiers do, where they ski off of cliffs and then open a parachute, which is cool, but I haven't done that. Go. We all already know slope equals m, but you'll notice I got a whole bunch of space here because slope equals a lot of crap. The first thing we're going to write is slope equals important. Oh, I didn't finish at the top. This slope. How do I get from blue to peachy? No, that's supposed to be peachy. How do I get from blue to peachy? Do I go up at all? 0 over a positive change, right? Can I divide by 0? I can't divide by 0, but can I divide 0? I have no pizza. I'll give you half. How much pizza are you getting? How much pizza are you getting if you're getting half of the pizza I have in front of me right now? I have no pizza in front of me. I'm going to give you half. How much are you getting? None. This is a 0 slope. Because again, you can't ski it. Although you can do better on it on skis than you can on a snowboard. Because, of course, on skis you can skate or use your poles to push you along. On a snowboard, you have to do that dumb hoppy, hoppy, hoppy thing where you look like an idiot. You've all seen snowboarders. Hoppy, hoppy, hoppy. They look like morons. Except for the good ones that can do that walkie-walkie thing on the nose and the tail of their board. Have you seen that move? Do any of you snowboard? No? Yes? Well, you know the walkie-walkie move? That's cool. Do you do that or do you do hoppy, hoppy, hoppy? You do hoppy, 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 don't you? And you look like an idiot. Or you try to do that. Not, you know what I mean, Kenzie, because I look like an idiot when I snowboard too. Sometimes I take on my back leg and I try to do that skateboard thing, but you look like an idiot doing that too, because you're either like this, or like this with your foot behind your snowboard. You look like a moron. When I snowboard, I like to carry one collapsible ski pole in my backpack. And then when I get stuck, I reach back like a sword, and I pull it out, and I go, and it goes shrunk, and then I push myself along. And all the snowboarders are like, you're an idiot. And I'm like, see you at the chairlift, idiot. And I'm already there. Because they're unbuckling and hoppy, and yeah, whatever. They really say I look like an idiot because I'm old, and they don't think old people should snowboard. But what are you going to do, right? Okay, back to this. Slope equals all these things. Slope is a very important concept. We use it. What the halibut just happened there? What just happened there? I've never hit that button before. Okay, we're back. It is M, we've already talked about, but it's a whole bunch of other things. One, it's a rate of change. You don't have to write all this down. But I'm going to write it all down. It is also change in dV over change in IV. It is also change in Y over change in X. It is also the rise over the run. Rise is how far we go up or down divided by how far we go side to side. It is also y2 minus y1 over x2 minus x1. What? What do we call the answer when we do subtraction? What is the answer in a subtraction problem? That's division. What? Difference, right? So this would be the difference of y's, right? Isn't the difference in y's the same as the change in y's? Because if y is changed, they must be different, right? So that's why this one works. And we're going to talk about all of these interchangeably through this whole unit, because slope is all those things. Everybody cool? All right. Turn the page over. Let's do some work. What do you notice about all of these four functions? What do you notice about them? They all have x, and the output is isolated, isn't it? If the output is isolated, then they are all in this form, aren't they? Which means that number that's all by itself is what? The y-intercept. So I'm going to use different colors for all of them. Where am I going to put the blue y-intercept dot? At -4. 1, 2, 3, 4. Now, if I'm going to draw a line, I need two dots to connect it, don't I? Well, how do I find that? I know that the number that is with x is the slope, right? 2 is really written how? It should be 2 over 1, shouldn't it? And isn't that a rise over a run? Rise up 1, 2, run 1, because they're both positive. Now here's the thing that kids always screw up. You know that this line will go up and over for how long? Ever. But you always forget that that line will also go down and left 2. Down 2 and left 1. Down 2 and left 1. You always forget that the line goes in both ways. As soon as you see positive slope, you all go up and right. Always. Every single one of you. Every kid I've ever taught from the beginning of my teaching career. The first few times they do this, they always, for positive, go up and right. Always. Which is great until I give them a y-intercept up there. And then they try to go up and right. Now, and then they draw more graph so they can go up and right. And they keep drawing more graph. Oh my goodness. You're not 5-year-olds. It would go down and left. Down and left. Everybody cool? Okay. So that's the first line. It's going to go right there. I'm going to try to draw it freehand. Well, that was pretty straight. I'm pretty impressed with myself. Where do I put the red dot for the g of x? Up to 1. What's my slope? What's the number that I don't write as a coefficient? 1. So this is really negative 1, right? Which is really negative 1 over 1, right? So how do I do that? Down 1 and right 1. Or up 1 and left 1. And then I connect the line. Easy peasy lemon squeezy, yeah? What do I do for C, h of x? Where's the green dot go? Up to 5. 1, 2, 3, 4, 5. And what's my slope? Up or down from here? Either one. If I go up, where am I going? Left. 1, 2, 3. If I go down, where am I going? Right. 1, 2, 3. And I make that line. And lastly, we'll use pink. Ooh, weird. Where's the pink dot go for the y-intercept? Zero. And what's the slope? 1. How do I do a slope of 1? Is it positive or negative? So is it up 1 and then to the right? Could I go up 7 and right 7? Would that give me 1? Could I go up 23 and right 23? Could I go down 47 and left 47? Yes. And there's that line. Can everybody do this? For most of it, your second time through. Can everybody take any equation with an isolated y and put it on the graph? Everybody? Good. This section is here to remind you for your test that you're about to write. Could everybody still do this? You should be able to. You should be able to do it graphically and algebraically, right? If I were to do it on a graph for f of x, what color line would I go to? Blue, red, green, or pink? Blue. And that is what? An x value or a y value for f of 2? That is an x value, so I would go out to 2 right there. Well, that's a pretty easy one, isn't it? What's the y value right there? 0, right? So the f of 2 that's supposed to be blue. The f of 2 equals 0. How would I do it algebraically? Well, the f of x was 2x minus 4, right? But I don't want the f of x, I want the f of 2. So it's 2 times 2 minus 4, which is 0. Everybody can do this, right? Algebraically and graphically, yeah? This is a review from your last unit. Because I always get this lesson done before the kids are ready to write their Unit 5 test. Do I need to do all of these, or is everybody cool? Everyone's good? Everybody remembers how to do function notation? Both graphically and algebraically? I hope so. Huh? All of you? You want to do B? Okay. So what color is the H function? What color? Green. So that is H of 3. Is that an X or a Y value? X. So I go 1, 2, 3, and I got to find the green line. It's right there. So what's the value? 4. H of 3 equals 4. Or the h of 3 equals 1/3 times 3. What was it? Plus 1, right? Or plus 5. Negative 1/3 times 3 plus 5. Negative 1/3 times 3 is negative 1. Plus 5 is 4. Do it algebraically or graphically. Everybody good? What's the difference down here? Do I go on the x-axis or the y-axis? Y-axis. What about here? Y-axis. Everybody should be good, yeah? Okay. Now we are going to stop there, and you're going to work on page 124 and 125 until... Well, 10:40 seems a long way away. That's an hour. I'm going to give you half an hour to work on that before we move on to number 3. I want to keep these 2 lessons of slope together as much as possible, because for some reason kids have trouble with slope. I don't know why. It's on the graph, but kids have trouble with it. So I'm going to give you half an hour to work right now on page 124 and 125. Go. All right, we are on page 126. Remember, the key to slope, all those things that it is, the easiest way to think about it is rise over run. Up and down, over side to side. It doesn't matter about anything else. Oh, excuse me. Ooh. Every single person put a dot anywhere in this section. Anywhere. Put a dot. Anywhere. I'm going to put mine there. Now, I want to draw a line with a slope of 2/5. But I want to stay in this quadrant if I can. So, can I go up 2 and right 5? No. Can I go down 2 and left 5? Yes. 1, 2, 1, 2, 3, 4, 5. And there is my slope. All of you should be able to do that. And no matter what, it should all look like that. You should be able to make this triangle. 5 and 2. Can everybody draw it? Excellent. In the quadrant right below it, right here, put a dot somewhere. I'm going to put mine there. Now I need a slope of -4, and I want to stay in this quadrant. Can I go down 4? I can't guarantee that that's right at the end, can I? So what would I be better to do? Up. 1, 2, 3, 4. If I've had to go up, where must I go to make sure I keep a negative slope? Left. Don't say over, say left. And that will give me this triangle. 4 and -1. Because 4 divided by -1 is indeed -4. In this quadrant, I want a slope of 0. Put a dot somewhere. How do I make a slope of 0? Horizontal or vertical line? Horizontal, the one you can't ski or snowboard down. And lastly, down here, I want one with a slope of 7. That's a steep slope. Is it possible to keep it in this quadrant? Look at it. Think about it. Where can you put your point to keep the entire line segment inside this quadrant. Where do I need room? Up and down or left and right with a slope of 7? Up and down. So I'd better put my dot somewhere near the top or the bottom. I'm going to put it here. Slope of 7 means up 7. 1, 2, 3, 4, 5, 6. And right 1. Please notice that the higher the number, the steeper the slope. Everybody cool? Easy peasy lemon squeezy. You all know how to do it already. This is just a reminder. I'm going to zoom in to make this easier to see, even though there's no real need to, because you're all brilliant. Where do I put point 1? Guide the pink dot. Guide me. Left, how far? 1, 2, 3, 4, 5. Then what? Down, 1, 2, 3. Where do I put the blue dot? Right 2, up 1. And I make that line, yes? Now, since it's on the graph, if I want the slope, all I have to do is count. Rise, 1, 2, 3, 4. I went up 4, so is that positive or negative? Positive. And I went 1, 2, 3, 4, 5, 6, 7 to the right, which is also positive. So the slope here is rise 4 divided by 7, run. Now, some wise ass always says, I want to go the other way, thinking they're going to trap me and make me look stupid. Of course, what really happens whenever you try to make me look stupid is you end up looking that way, and you don't want to do that. 1, 2, 3, 4, negative 4. 1, 2, 3, 4, 5, 6, 7, negative 7. Negative 4 divided by negative 7 is still 4/7. Okay? Okay. The other one, just by looking at it, what's its slope going to be? Without even drawing it. What do you see that's the same? 0 and 0, right? So it's never going to move from 0 on the x-axis, is it? So it's going to be straight up and down, isn't it? Which is what kind of slope? Undefined or infinite. When it's on the graph, when graphed, you can count for the slope. If it's on a graph, just pick 2 points and count. Then you can't screw it up. Okay? Okay. Turn the page over. K and L, are they graphed? No, they are not. You could graph them and then you could count, or you could remember one of the other versions of slope, which was Garumph. Which was change in y over change in x. If there's a change in y, there must be a difference in y values. If there's a change in x, there must be a difference in x values. Why do I have to have the little 2 and the 1 there? Because if I don't, in algebra, y minus y is 0, isn't it? So I have to put the 2 and the 1 there because I have one y value and a second y value. And I have to put the 2 and the 1 there for x because I have two x values. Now here is where kids always screw this up. If I make this guy y1 because he's the first y I see, what is this one? x1. You can't screw that up. You gotta keep the order. Which makes this guy what? x2. If you know this, and you don't even have to memorize it because it's on your formula sheet, you can always do this. Again, all we do is we take the value from the question and we put it in. y2. What number is y2? 1. Minus, what number is y1? 7. Over, what number is x2? Negative 6. Minus, what number is x1? 2. 1 minus 7, negative 6. Negative 6 minus 2, negative 8. What's my slope? Positive 3/4. Because Mrs. Bad Crumble would never let us leave that fraction. Right? Thank you, Mrs. Bad Crumble. If I had enough coffee, I'd pour some out for my homies. But I don't. I say this because a very great many of my teachers in my past have died. Because they were old. Soon, one day, you too will say, man, you remember that grade 10 guy we had in summer school? He dead. And you'll all be like, oh, pour one out for my homies. But you won't be drinking coffee. You'll be drinking some other weird drink because coffee won't exist anymore. Because coffee is evil. Now, what does some wise-ass kid always do here? What does some wise-ass kid always say when I'm done? What? Oh, I don't want that one to be x1 and x2. All right, fine. x2, y2, x1, y1. And you would get 7 minus 1 over 2 minus 6, which is 7 minus 1 is 6. 2 minus 6 is 8, which is 3/4, which last I checked equaled 3/4. Always some kid, I don't want to do it the way you want to do it. If I do it the way you do it, then I'm just, Fine, kid. Do what you want. What's the first thing you need to do over here? Label your X's. Label your Y's. If you label your X's and Y's, is it possible to do this wrong? Do you even have to know anything? No, because I give you this formula. It says right on your formula sheet, slope equals y minus y over x minus x. And what do you see right here? X, x. Oh, there's 2 of them. 1, 2. Y, y. Oh, there's 2 of them. 1, 2. This is really hard, Mr. Myers. I don't know how to do it. Okay, kid, let's go through it. y2 minus y1 over x2 minus x1. Oh, man. y2. How will I ever find out what y2 is? Oh, I have 2 y's right there, and I actually labeled one y2. Fitting. Minus. Oh, y1. This is tricky. I don't know. y1. 4. Negative 5 minus 1. What is it? What's the answer? No, of the whole thing. 11 over. It makes me so sad when my 10th graders can't add. hang your heads. Shame upon you all. It's adding. You tell me what math is easier than adding and subtracting. Multiplying is easier than adding and subtracting. Okay. What's 121 plus 21? Huh? 142. What's 121 times 21? No calculator. Uh-huh. Adding's easier. Uh-huh. All right. So let's look here. Are these graphed? So how should we find the slope? I lied. There is an easier math than adding. Counting. How will we find these slopes? We'll count. Like the guy in Sesame Street. Every time we say a number, lightning will crash and thunder will rumble. Do you know whom I speak of? You all know who I am talking about, right? You know he died? Not the puppet, the guy whose head was in the puppet's butt. He's dead. Puppets can't die, Harvey. They're not alive. Well, how do you think the Muppets work? Puppets need somebody inside them. No. It depends on the puppet. You think there's a guy whose hand is big enough to be inside Big Bird?
That's not a puppet, though.
What would you call Big Bird? A mascot. Yes, but the Muppets don't have a hand inside them. The Muppets aren't puppets. Bert and Ernie aren't puppets. What do you call Bert and Ernie? Mascots. Bert and Ernie, the Count, Kermit the Frog, they're not puppets. Kermit's a puppet.
Yeah, but you said that. Whose head's going to fit in Big Bird? Whose head's going to fit in Kermit? Who's going to fit?
Muppets do not have hands inside them.
Yeah, but does Kermit have a human inside?
No. He's got sticks. That's how Muppets work. If you watch the Muppets, the movie, they're on a stage. And everybody is below them moving the puppets. And the actors in the movie are up on that stage with them. That's how the Muppets work. Anyways, back to Muppets. How will I do this one? Will I count from that point to that point? Of course not. Why, Parm? Pardon me? Well, no, it wouldn't be a positive slope because I would go up and that would be positive. I go that way and it would be negative. Why can't I use the two endpoints? It's not exact. How far up do I go here? I don't know. So if you don't have exact endpoints, you have to choose your points. Tell me when to stop the dot when I'm at a good spot to start counting for slope. Now I'm going to hum the theme song from the Price is Right game show, The Mountaineer. Do you guys know the one I mean, that game? Okay. So now I would go up to the end and over, right? No, why not? Because it's still a crap point. So I got to get another point. Oh, good, because I didn't have another octave. I was out, man. I got a low, bad singing voice, so that I started an octave way too high to go that far up the line. Now, what's the slope? Parm, hit me. You're not Parm, and you're wrong. What is it, Parm? I just said 7 over 2 was wrong, Parm. What's the slope? What is it, Parm? Right, it is 7 over negative 2. Now, please be aware, this is another thing kids cannot get their head around. Negative 7 over 2 is the slope. 7 over negative 2 is the slope. Negative 7/2 is the slope. All 3 of those are acceptable. Okay. All right, what's the slope in B? Where can I start? I'm going to start up here and go for a slide this time. Okay. Okay. And what's the slope? What's the slope? What's the slope? Parm, I'm going to give you a chance to redeem yourself on first try. What's the slope? Don't say it. This is Parm's chance at redemption. What? Negative 3? Negative 3? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 3 7s. Nice. What's straight up and down? Undefined. Or infinite. What's flat? 0. Why? No fun to ski. Hoppy hoppy, right, Kenzie? No fun at all. Also no fun to ski. Death. Ah! Don't ski down those. You die. Everybody do number 4 right now. Everybody, all I'm asking you to do is draw a triangle. How hard can it be? Almost as easy as counting, adding, and subtracting. All right. It's taking a long time to draw a triangle, man. I can draw a triangle in 1 second. Let's draw a triangle, ladies and gentlemen. It's only 3 lines. Tough guy, huh? Everyone's a tough guy until you got to prove it. Put your money where your mouth is, Harv.
So we're putting money on this? We're doing some money out there.
If I pay you, you will do this. Do you know how much money you earn in your life because you get a high school diploma? No, it doesn't depend. There's plenty of studies on it.
I could get money without
Kid A drops out of high school, doesn't get a high school diploma. Kid B gets a high school diploma. They both work until they retire. How much more money do you think Kid B that had a high school diploma makes? Take a guess.
It depends on what you do.
No, it doesn't depend. I'm asking you on average. It's a study. Everybody talks about this stuff. Yes, maybe I'll win a $50 million lottery ticket and I'm a drunken dropout loser. Yes, I earned $50 million in my life. But that's not the average. A regular, everyday kid.
I don't know about average because I'm not average.
Okay. Anyone want to take a guess? How much money your high school diploma? How much money your high school diploma is worth to you, on average?
Nothing. It doesn't matter if you have a high school diploma. It
Huh?
depends if you get a job after that.
I'm aware of that, but I am asking you, at the end of your work life, studying hundreds of thousands of people.
Per year or like
No. Over the course of your life, how much more money do you think somebody who graduates from high school makes than somebody who doesn't?
do you go to college?
I didn't say college. All I'm talking about is high school. Because college, high school, you guys all give me that line of horse crap about how we don't get paid to go to school. So I'm asking you.
I'd say 500,000.
Exactly. $500,000 difference. Exactly. which means one course in high school will earn you $16,000 over the course of your life.
That's if I pass the course.
Yes, it is if you pass the course. Now,
What if
am I teaching you guys a course right now?
Yeah.
If you pass it, am I worth 16 grand to you now? I am. You guys feel free to write me a check when you're 65 and have retired for $16,000. You know what? I like you so much, I'm give you a deal. You cut me a check for 10 grand. That's like 40% off. What?
If I stop going to the gym now, by the time I'm like 90, I'll have 15,000 saved up. I'll just give you that.
Sounds good. And then we'll meet on the field and play some football later where it's free. So yeah, that line about how high you don't get paid to go to school, that's a big old line of horse crap.
No one said that.
You guys say that all the time.
I don't. I've never said that.
Kids say that all the time.
I've never said that.
You just did say you wanted me to pay you to do your math work.
You said put your money where your mouth is.
That's a bet. That's different.
Yeah, so we're betting money. What else do we bet?
You can bet anything. Whatever you decide is currency is currency.
You said money.
It's a saying. I also say it's raining cats and dogs. When you go outside and it's pouring rain, are you dodging them? Meow! Woof! Oh! No, it's just a saying.
If I ask you what the weather
It's as hot as hell out there. Do you really think?
probably is,
No, it's not. You're a crazy man.
no, this is different though. It's not the same thing.
It's a saying.
That's like exaggerating a saying.
It's a saying, Harvey. People say, put your money where your mouth is.
No money, then what are we betting here?
We could bet anything. You choose.
Money.
No, I can't bet money with a student. That's illegal. I would get in trouble.
So all I gotta do is draw a triangle.
That has three sides have a positive slope, just like I asked you to do.
And then I get a whole bucket of gummy bears.
No, you don't get a bucket of gummy bears. You're drawing three lines. What makes you think that's worth a bucket of gummy bears? It's three lines.
Never do something you're good at for free.
You're not doing it for free. How many gummy bears you got in your hand right now? So if I give you one gummy bear, technically you have infinitely more gummy bears than you have right now, right? Because between 0 and 1 is infinity. Right? No, you don't guess. That's true. Ask anybody. 1 is infinitely more than 0. So I will pay you an infinite amount of gummy bears to draw three lines.
Yeah, but that would be I get one whenever I want.
No. You would get one right now because you did the job once. What, you think I get paid next year for teaching you guys?
You get paid now for teaching.
Yeah, once. I get paid this month for teaching you right now.
No, but that's different. That's like you come to one class and then they pay you for that and then you never get paid again. Like it's the same class, you're just doing it 30 times. See, one line is one gummy bears. If I'm doing it 3 times, I get 3 gummy bears.
But no, because you have to draw a triangle. So to complete the job, you must do one thing. It is made up of 3. That's like saying, build me a house, Harv. Okay, I'll pay you $10,000. You build one wall. Can I have $2,500 right now? No, you get the money when you build the house.
You do the math when you do that.
Mr. Weed would like to see
When you get your house built, you go wall by wall. I'll pay you this much for one wall.
two couples residents, please come and see.
I don't understand.
That's not how it works, buddy.
Yeah, when you get your house built.
Yeah, you pay the guy when the house is built,
Yeah, but you pay
not
for each
halfway.
wall, basically.
No, you don't.
Yeah, so once I'm done the triangle, it's built.
Yes, and you would get your wage, which is one gummy bear.
That's not fair though.
That is fair.
One
You get
gummy
paid
bear
when
is
you
a
finish the job. That was a good debate. I recorded all of it. Meanwhile, I'll draw positive triangles. Done. Because you had to make sure you went up and to the right. Now, a lot of you went down there. That's a negative. You got to go up and to the right, but not as steep, and then it's easy to connect. All right, we're going to do like 4 more together, and then I'm going to let you work. When you work, of course, you have the choice of working on the current stuff or preparing for your test or a mixture of both? Okay, so x and y intercepts. As soon as I see x and y intercepts, what should I be thinking? X, 0, and 0y. Now, these are x's and y's. What do you see there and there? X's and y's. So all you do is work it out. Now, I would move one of these terms in this trinomial. What would I move, do you think? You have two choices. You could move 2y and then do some isolating, or you could move 8 and then do some solving. Either way would work. If you move 8, you get 3x minus 2y equals negative 8, right? When I'm doing this line, y is 0. So what happens to this? It disappears. And I get 3x equals negative 8. So x equals negative 8 thirds. 3x minus 2y equals negative 8. What happens when I'm doing this? What happens to the x? What happens to that? It disappears. So I get negative 2y equals negative 8 and y equals 4. Now, soon as I got that fraction, should I run over here and put it on the graph? No, because it's a fraction. Whenever there's a fraction, I probably want to change the scale, right? So this is thirds, yes? So where should I put my number 1 on the x scale right now? If I need 8 thirds, where should I put the number 1? Should I put it here? 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 Yes or no? If I put it here, then how much is that? That's a third. And I need negative 8 thirds, don't I? So right now it's set up so each square is a third, yes? So how do I get to negative 8 thirds? Count to 8 in which direction? Didn't I want negative 8 thirds? Left. 1, 2, 3, 4, 5, 6, 7, 8. That is negative 8 thirds because I've changed the scale. Now, I have a problem because my y is 4, right? Now, if I keep this same scale, 1, 2, 3, that's 1. 1, 2, 3, that's 2. 1, 2, oh no. I would go off the graph. Does Mr. Myers want me and all your other teachers to draw more graph? No. What do we want? We want you to recognize, all right, I can't change the y scale, so I'm going to leave it the same. 1. Now, you have now shown me that your y values, each square is worth 1. Your x values, each square is worth 1/3, right? So I will go up 1, 2, 3, 4, and I will draw that line. Everybody should understand that that's how we do it, yeah? Now, here is what will cause you grief. If I were to ask you the slope of this, half of you would do this. 4 over 8. And tell me the slope was 1/2. How many of you thought, as soon as I said slope, how many of you wanted to draw that? I hope none of you. Because, of course, it's not 4 over 8, is it? What is it really? 4 over, what's this? Negative 8 thirds. Right? So the slope is actually 4 over negative 8 thirds, which is 4 divided by negative 8 thirds, which is 4 times negative 3/8, which is negative 12/8, which is negative 3/2. Sometimes when you graph, you can't count. When are those times? If the x and y scales are different, we can't count for slope. Does everybody understand that? You have to use the actual values. Everybody cool? Okay. Alrighty. Now, here I have a problem. What's that? That's an x. It's the first x I see. I'm going to call it x1. That's the first y I see. I call it y1. x2, y2. And I've got a slope of 2, so that is m. Everyone agree? So I can solve this problem in two ways. I can solve it algebraically, or I can solve it graphically. Which way do you want to do first? Algebraically? Okay. So, in algebra, I know that m equals y2 minus y1 over x2 minus x1, right? Now all I do is fill in all the parts. m 2 over 1, because that's what this really is, right? y2, oh, okay, y, minus y1, okay, 6, over x2, negative 4, minus x1, 2. 2 over 1 equals y minus 6 over what? Negative 6. Yay! How do you solve every single piece of algebra that is fraction equals fraction? What do you do? What kind of multiply? Pardon? You cross them. What's 2 times negative 6? Negative 12 equals 1 times y minus 6 is y minus 6. What do you do with that 6? Bring it to the other side and it becomes what? Positive 6. What's negative 12 plus 6? Yeah! Y equals negative 6. Ease, peasy, lemon squeezy, right? All right. Now let's do it graphically. Which of these 2 points am I able to put on the graph right now? Point A or point B? Point A. I would go out 1, 2, and up 1, 2, 3, 4, 5, 6. Agreed? What do I know about point B? Y is negative 6. Pretend we haven't done the algebra. We're doing this graphically now, Madeline. What do I know about B? I know x is negative 4, right? So x, the other dot, has to be somewhere on this line, right? Because that's negative 4. Everyone agree? And I know the slope is 2, correct? So I got to keep my slope positive, but I got to get from this point over to here. So is that up and right or down and left? It's down and left because I got to get over to this line, right? So if I go down 2 and over 1, am I at that line yet? Nope. Down 2 over 1, am I there yet? Down 2 over 1, still not there. Down 2 over 1, still not there. Down 2 over 1, still not there. Down 2 over 1. Oh, there's my point on that line, which I know is negative 4 and negative 1, 2, 3, 4, 5, 6. You must be able to work with both algebra and graphing. Everybody cool? All right, prove it. Put your gummy bears where your mouths are. Do number 7. Graphically and algebraically. Do I care which one you start with? No. Go. So algebraically, I'm going to make that x1 because it's the first one I see. y1, x2, y2. Slope of -3/2. So m equals y2 minus y1 over x2 minus x1. If I write it out, it's impossible to do wrong. -3/2 equals -4 minus 5 over x minus -1. Then I rewrite it so it's pretty. -4 minus 5 is -9 over x plus 1. Then I cross. -2 times -9 is -18 equals -3x minus 3. Bring that over. Plus 3, -15 equals -3x. Divide by -3x equals 5. There's my answer. Now, if I'm going to do it graphically, I go to -1, 1, 2, 1, 2, 3, 4, 5, right there. And I know I need to get all the way down to y equals -4. 1, 2, 3, 4. Right here, where y is -4. And I know my slope is -3/2. So I go down 1, 2, 3, and to keep it negative, I go right 1, 2. Not there yet. Down 1, 2, 3, right 1, 2. Not there yet. Down 1, 2, 3, 1, 2. Oh, there I am at 5. All right, what's the answer? X is? X is not -7. X is 5. X is 5. And you do one of these two. You either work it through algebraically or you work it through graphically. I am betting that most of you screwed up there and you forgot that x minus -1 is x plus 1. I will let you have a look at that for a moment because you know as well as I do, because half the class screwed it up. Guess what the next question is? It's the exact same thing, because that's how you get better at stuff. You don't sink one free throw and say, all right, I'm the best free throw shooter in this team. I'm going to shoot every foul shot because I'm the best, because I shot one and it went in, so I get 100% of my free throws. Some of you may remember the famous basketball player Shaquille O'Neal. And some of you may know that Shaquille O'Neal was worse at free throws than me. And at one point, it became a strategy of the defending teams. They would foul Shaq every time he took a shot because he missed more than 50% of his free throws. It's a smart move if you know somebody on their team cannot shoot free throws. Foul the crap out of them. And they miss the free throws all the time. I did not just tell you to cheat. All right, number 8, here's your chance to do it right. Yeah, that recorded. Here's your chance to do it right. Number 8, algebra and graphing. Go. I'm going to pause this one. I'm going to turn off the screen. I'm going to do all the work. And if I get a bunch of you going, rah, and it's wrong, we'll do the last one together, because apparently we need to. All right, algebraically, I'm going to call that guy x1. I'm going to call that guy x2 and call that guy y2, because I want it to be x minus in the end, which makes that x1, and that makes that y1. and my slope is 3. So there's my m. So m equals y2 minus y1 over x2 minus x1, 3 over 1, because 3 is really 3 over 1, equals 7 minus 5 over x minus 0. 3 over 1 equals 7 minus 5 is the same as 7 plus 5, so that's 12 over x. 3x equals 12, because right there I cross. X equals 4. Now, let's do this graphically. I know I have a point at negative 0, negative 5, right there. And I know I have to get up to y equals 7. 1, 2, 3, 4, 5, 6, 7. Here is where I have to get all the way up to. I know my slope is 3, so that's 3 over 1. 1, 2, 3 over 1, not there yet. 1, 2, 3 over 1, not there yet. 1, 2, 3 over 1, not there yet. 1, 2, 3 over 1, there I am. And I check, and lo and behold, 1, 2, 3, 4, x equals 4. All right, everybody got it. Now, last one, and then I'm shutting up and you're working until 12:05. Okay. We're going to do this one together. What should I make this guy? X1 or X2? You want to make this guy X1? So that means this guy is what? Y1. That makes that guy x2, y2, and there's my slope, right? There's my m. If I write it out, I cannot possibly do it wrong. It is impossible to do the grade 10 part of this wrong. It's possible to screw up my grade 3 algebra, isn't it? But it's impossible to do the grade 10 part wrong if I write it out. What do I put in for m? 5 over 2. What do I put in for y2? Negative 2. Minus, what is y1? Y. Over, what is x2? Negative 3. Minus, what is x1? Tidy it up. 5 over 2 equals negative 2 minus y over what? They can count. Now what? Cross. What is 5 times negative 5? Negative 25 equals, what is 2 times negative 2? Negative 4 minus 2 times y. 2y. How do I solve that? What happens with this 4? Plus 4 first. Negative 21 equals negative 2y. What does y equal? Not negative. It's 2 negatives. Y equals 10.5, yes? Because half of 21. I divide 21 by 2. Right? Yeah. All right, now let's do that graphically. I know negative 1, negative 2, negative 3, negative 1, negative 2. I know I need that point, yes? And I need to get out to where x is 2. Here is where x is 2. Let's check. Up 5. 1, 2, 3, 4, 5. Over 1, 2. All right. Am I there yet? No. Up 1, 2, 3, 4, 5. Over 1, 2. Am I there yet? No. Up 1, 2.